Okay, after installation of the firmware, we will click on the mandatory setup, and then we will go to the mandatory hardware. And in the mandatory hardware, first option we will see axial calibrations. Axial calibration we will click upon, and see says calibrate axles. When we will click upon here in Excel, it will say please place the vehicle field. So it means
place vehicle level and press any key.
So he says that press vehicle in a level and press any key. Okay, where it is in a level position. See, vehicle is in a level position, and we will press this. Now he says that place vehicle in a left side. So left mean we will keep it in this left direction, as we have keep it in a left direction. Now he says that place vehicle in a right direction. So it is in the right direction. Now we have to place it in a nose down. It is a nose down. I see it's a nose down. Now it is nose up. As you see, it says nose up. This is a nose up direction. This to keep it in back.
Calibration failed.
If the calibration is failed, we have to revise the same procedure. If the message is sound calibration failed, you have to revise the same procedure. First frame have to move to the left, then right, then nose down, nose up, then back, then front. Then you will find a message that calibration successful. When they found the calibration successful, then we have to calibrate the compass. By clicking compass, we will see here there are the two type of the compass. One is use compass 1 and use compass 2. If you have two compasses, one compass is already built in this microcontroller, and second compass is this one we are using here. So if you have only one compass, that is mean you do not have this compass, and you have only one compass that is here, so you will uncheck this one. Okay, but you have two compass. Since right now we have two compass, we will so we'll click here in the start, and after clicking here, so we have to rotate the frame in all the dimensions. When we click upon start, it will start completing the two compasses, and we will rotate the frame in all the dimensions. As you can see, I am rotating it in all dimensions, left, right, up, down, until even back of this way. It's a very little kind of different and tough, but be carefully do this one. And you see that all bars are going to be complete. I am still rotating the frame in all dimensions.
MagCal, no location, fix _ radius skipped.
And it will say that now reboot. I will press reboot. Okay, it has rebooted. Nice. And I will see that it has completely done. Now we will click upon the radio calibrations. For radio calibrations, it's necessary that our receiver be connected, and transmitter will also be binded with it. So our transmitter and receiver also binded. The binding symbols that this light was the blinking first of all, but now it is stable. So stability means that our transmitter receiver both are the binded. And also when we turn it on, we see that calibrations bars are lighted up. So now we have to remove all the stick up and down and in different positions. Like this is a throttle, so we'll keep it up and down by clicking here radio calibration. We'll click on the radio calibration, and it says that they must have to be on. Now you see these are the red lines are here, and these red lines have to be moved. How much we want a throttle, we will keep it up. Since I have adjusted throttle very less, not a very high, so I will use these configurations. In the same way, I want left and right not 100%, so I want only a short left and right, as this is the pitch up, this is pitch down, this is right, and this is the left movement, and this is for that's mean when we are arming we will use this key, and we will completely rotate it to the right side for arming, and for disarming we will completely move to the left side for disarming. For throttle, I will use a very less throttle, so that I do not want a high level altitude, so I will keep it a short throttle. As you see here, this is a throttle pin, like this way, this throttle. And I have assigned this switch for some modules, like stability model and the Lytle models, so I will use it as a second switch and third, first, second and third. So radio calibration is necessary for this one also. So now after this one I will click when we have done. Okay, and then okay. Now it has been completed. Sign says that it is completed. Now we will do ESC calibrations, and after connecting ESC, it says that we have to first of all put a battery, so that when we click upon this one, click calibrate ESC, it says that after pushing this button, disconnect USB and battery, and then reconnect, and then plug in battery. And after, when the this LED is flash in different colors, we have to press the safety switch. This is the safety switch. We have to press this pressing in, it will reset it. I have plugged in battery, as you can see here, and now I will click upon this button. After clicking, I have clicked. Now I have to disconnect battery and USB. I have disconnected USB, and I will also disconnect this battery. See, I have disconnected battery, as well as I have disconnected from USB from the modules. Now I will reconnect the battery and press the safety switch. I have reconnected the battery again, and I will wait until a sound will come. And now I will press the safety switch. It's give three pins, three sounds, and a fourth sound was little longer. That indicate our ESC has been calibrated. When our ESC is being calibrated, we will reconnect our USB or controller to the mission planner, and we will go to the optional hardware, and in optional hardware we will go to the motor test. Here in the motor test, we have to set the throttle level 5% and for spinning for the 2 seconds. And now we'll see motor A, B, C, D. So motor A, that is 1, that must be a counterclockwise. So here we will see we have mentioned this one as a motor clockwise, counterclockwise.
Motor test, RC not calibrated.
It says that motor test RC not calibrated, mean we have to press the safety switch. After successful calibration of the radio transmitter and receiver, we will click upon motor test 1. Here and see our motor is spinning. We have to counter it. How does it is moving? So this is a motor 1 that is moving in a counterclockwise. This is motor 2. If this is motor 1, then this is motor 2, which also we have to move on a counterclockwise. So this is moving in a counterclockwise. So in the same way, this is the motor B. So we have to see that how it is moving. And this is the next motor. This is motor D. So all the motor, we can click upon test all motors and see all motors are moving. And more important thing, during arming, this is the arming set. So arming must be less than a minimum spin. So if we keep arming 4, okay, and the minimum spin arming must be 5. So min spin must be greater than the arming spin. Arming spin must be less than this. Is that okay? Okay. So we have see all motors are moving in a proper way. We have test all the motor by clicking here. If you will click, and you will see all motors are moving. So all motors are moving. So in this way we will configure our software with motor test. Now before to put propellers, I will arm with the transmitter and see is the motor spins at the same time or with a different time. If the motor are spinning in a different time, that's mean motor ESCs does not calibrate it properly. Now at the end, I will arm my quadcopter that is completely built up and see the behavior. See, LED is flashing continuously, and if we will try to arm, for arming we have to move this stick to the extreme right. It is not arming, so we have to press this safety switch or reset button and see what does it done. If it is not responding, that's mean we have to restart. We have to reopen the battery and reconnect it. I have reconnected the battery, and now after listening these beeps, I will press the safety switch. Battery gives some alarm, they are ready, and now see LED color is changed. Now it is blue color. When the blinking is blue, then it is ready to be armed. Otherwise, when it is yellow or 7 segment like color, different colors, then it will not be ready to be armed. Now I will arm. I will move to the extreme right. This beep indicate and light stability indicate it is armed. I will move the throttle little high and see they are moving, spinning. It seems as calibration is not perfect since motor are spinning very high, and when I am keeping it at 0 level, motor stopped after some time. It means something is problem in calibrations. I will recalibrate the ESCs. For calibration of the ESC, I have to disarm. For disarming, I will keep it in most left, and then I will have to move the throttle at extreme high level. Okay, after this one extreme high level, I will disconnect the battery. I have disconnected the battery. Now I will connect the battery and listen the beeps. I have connected battery. When the light will start flashing, I will disconnect battery now once again. I have disconnected the battery, whereas throttle is at top level. I will reconnect the battery again. I have reconnected the battery, and when the light will flash, I will press safety switch and will down the throttle. Now listen. Yes. These after short 3 beeps, a long beep indicate motor are armed completely. Now I will spin the motors and see motor are spinning normally. Initially the motor sounds indicate that their ESCs are not calibrated proper. Now a small sound and stop at when I zero the throttle, motor have to be stopped. Now in next video I will put propellers and will test it on a bench. Then after this testing I will move to the space or in ground.